You're listening to Raiding the Fringe with Poda, Ostinius, Nepids, and Dr. Lee. From ancient civilizations to the cutting edge of science, from exploring the outer reaches of space to the Atlantean depths, we discuss the topics of the unknown and the possibilities of the bizarre. Are you hungry to expand your horizons? Come get your fill as we raid the fringe.
Hello, everybody, and welcome once again to another episode of Raiding the Fringe. I'll be your host today, Dr. Lee, and with me, as always, is Poda.
What's up?
Ostinius.
Good day.
And Nepids.
Hello.
Today's Fringe topic is going to be quantum theory. We've done enough with the mystical. Let's take the sciencey edge of things for a little while and talk about the weirdness that is quantum theory for scientists. And so for some of you who aren't so in-depth knowledge, quantum theory basically, boy, you know what? Quantum theory is going to make your head spin. The more you know about it, the more it doesn't make sense, because scientists have had a trouble defining reality on a microscopic scale. So when they came up with quantum theory, the whole idea of how electrons can exist and non-exist in certain places and everything, the smallest packet of energy that can be is a quanta. And so they call it quantum theory. But it's this whole new branch that opens up into possible realities. It tries to explain black holes. It permeates into a lot of physics and current theories that scientists go off of, and it's all based off of this weirdness, this quantum theory that everything can exist and not exist at the same time, or exist in two different polarities. And this is a topic that I always like looking up the advancements and everything in this field. So I could go on forever. I'm going to pass it on to someone else to go ahead and get us started, talk about an angle or an aspect of it if you'd like. Because otherwise I'll take up the whole episode myself.
Well, I always thought it was really interesting, just because ultimately there are things that are quantifiable, but then like a lot of this is theory. So, you know, we know that energy cannot be destroyed. It has to be reallocated. And in scientists doing stuff with the proton accelerators and things of that nature, they say that there's these different dimensions, and ultimately it's because they've accelerated it to the point that we cannot perceive, and we say it's got to go somewhere. But on the other hand, that is just theory. So, I mean, it could be one of those aspects of the blind leading the blind, but these are our top scientists saying that. Now, it has, you know, shown us things with black holes, and some of the stuff, the theory has led to positive conclusions and, you know, hypotheticals and stuff, but we don't know everything about it. That's what makes it so weird, you know what I mean?
Well, yeah, but the idea of science itself is to find something that you can't explain, to try to explain it. So as long as there is something out there that weirds us out, that we can't figure out, then the scientists will always still have a goal.
True enough, yeah, to try to prove what this is or that is or what could be. But when it's all conjecture to a point, you know what I mean?
Well,
who's to say that what conclusions are correct?
Here's the thing, is it's not all conjecture, and the farther down the rabbit hole you go, it's a what if, and then they try to prove it, and then once they prove that, they're what if again, and then they finally got to the point where they've gotten all of the answers. Like every experiment they run, they can predict the outcomes, and it gets to a point where they're like, yes, this is great, but why? And that is where all the theory comes in, is to explain why the results are always coming up as they wanted to. One of the experiments that started off all of quantum theory was the 2-slot test.
Yeah, you're talking about the light wavelengths?
Yeah, because it acted like waves instead of particles going through two slots. You shoot a particle through a wall with two slots in it, you would think that eventually if you keep shooting things, it would make two slots on the back wall where you could get through and it would shoot. But with one of the holes covered up, that's how it happened. But with both of the holes opened, it interfered, and all of a sudden there were 5 slots instead of 2 of exposure on this back wall. And the only way to explain that is through waves, where energy is in waves instead of in a straight line or being one particle. And the reason that's weird is because it's not a wave of energy, it's a wave of possibilities that are happening all at the exact same time. Because when they're doing this, they are literally isolating one single photon and shooting it through the thing, and it ends up in 5 different spots.
Well, see that, yeah, and that's the trick too, because, well, I mean, it's also not they're shooting just one photon of light. They're shooting one stream of photons. So it's like a single file line, trying to go through a one area spot. And it is literally
one photon per 90 minutes.
That's not how I understood it. I understood it as like they've done it both, singularly, but then also, like the 300, the bottlenecking kind of situation. You've got the spray of photons, and you would figure since there's only one escape that they would stack up behind each other, but that wasn't the case.
Right, and that was how the experiment started. And that's when people are saying, well, duh, you got all this light bouncing around. Maybe it's bouncing off of the little edge of the hole that you cut, and giving you a slight refraction. When you're shooting a stream of light through there, you're seeing a possibility of it bouncing everywhere. But they had since then been able to devise a device that literally shoots one single photon at a time, and it still does that.
So what, does it become separated on the spread on the other side? You know what I mean? Like, so the one splits into 5, or what?
That was a theory as well for a while, but that would prove 1/5 of the brightness when it hits that back sensor wall, which wasn't the case. It was hitting at a full 100% in all of these different areas.
Then would it be the act of shooting it the way they're doing it, which is changing the way it operates?
After all of the experiments, this has been done by more than one person. This has been done over the last 70, 80 years. And it all falls back to this one experiment that started everything. They tried to rule out the way it's shot. They tried to rule out the way the wall has been made, the way the receptacle has been made. The 2 major theories going on with quantum theory is, the one is that it's possibly everywhere and it doesn't solidify until it's observed, which is what Schrodinger went off of.
Yes.
But Einstein hated that theory and fought against it. He's saying, no, you just don't have it all yet. You've got some good sound theories here, and the calculations are helping us out, but this is not complete. The reason you don't know exactly where this molecule is or whatever, where this photon lands, is because you don't know everything yet. Keep looking, keep studying. I believe that once you know enough, you can get precise with it again. And so that's basically been a big argument.
Didn't they come to a term of, it was ultimately dividing wavelengths and interfering with itself? Because, if it's separating into those separate wavelengths, you're going to have like the lighter wavelengths and the darker wavelengths, and that's going to interpose on itself.
That's the reason that they believe that it's in more than one spot at a time, because those waves can't be generated unless there are 2 separate waves from each of the 2 slots that are interfering with each other at the same time. If it was just one photon, like bouncing back and forth between the 2 holes, you wouldn't have that. Like, imagine dropping a pebble in a pond, and you see those ripples go out into a giant circle. You drop a second pebble about a foot away.
Pebble in the puddle.
The pebble in the puddle. And when those ripples start colliding with the first ripples, then they start either amplifying each other, making huge little parts, or the dips down, or sometimes it balances out neutral and is water level. If one ripple is up while the other's down, they can't
It'll
possibly turn
counteract
out.
it. Yeah.
And this is what they were seeing with the stripes on the back wall. That was the ripples from both holes, even though they shot one photon. So that's how they've decided that it has to be possibly going through both at the same time, but not actually, because it is only one photon, and when it hits that back wall, its journey's done.
Okay, so then how does the Schrodinger's cat thing play into that? Because, the Schrodinger's, for those of you who are not familiar, the idea of Schrodinger's cat is, you have a cat in a box, but until it is revealed, the cat is both alive and dead. Like, there's a infinite number of possibilities, but it isn't, 100% known until it's revealed. So how does this interact with that?
Well, when they did the study on electrons and photons on a microscopic level, they found that they have a specific spin to them. They call it spinning up or spinning down, the two basic characteristics of this particle. And all the math and everything they put into this, they've seen it jump from ring to ring around an atom. If you're picturing an atom like a solar system where you've got the nucleus
right.
and then you got the electrons floating around it, it'll jump from the first ring to the third ring to the second ring without moving in between. It's just there all of a sudden as the atom gets excited, with whether it's through heat or through energy applied to it. And because it can't move in between the two, they've decided that is the smallest increment energy can be at. The smallest packet that an energy can be in, and that's what they call the quanta. That's what makes up quantum theory.
Right.
So while they're in this state, they're either upspinning or downspinning, or they're upspinning and downspinning at the same time, coexisting in two different realities. Now, Schrodinger's experiment with the cat was to take this from an atomic level, making it bigger into something that can be seen and observed by people. So he stuck the cat in the box with a radioactive sample and closed the box, and then you don't know if that radioactive sample decays or not, or if the cat's alive or dead until it's observed. And that was to show that nothing is set until observing it sets it into place. And that's the one thing that Einstein called bullshit on.
It's true. If I started a Tinder account and, I didn't post a picture until I had that date, I'm both handsome and hideously ugly.
Yeah, exactly.
At the same time.
I just realized I find it interesting because I've looked into Schrodinger's cat and the possibilities of that theory, where every possibility is happening until it's observed, until it's measured. But I would always come back to, do we have any control over the outcome? Because if you
there are things that are a constant, as far as scientific experimentation and stuff like that. If there's certain things, okay, so if you put a mouse in a shoebox with a set mouse trap, you've got a way better chance that when you open that box, you're going to see a dead mouse in a mouse trap. You know what I mean?
Sorry. Well, I just meant because that's the perceived outcome. Are we, by putting that thought into that observation of expectancy, are we forcing the outcome? Because we could wait for the reaction of the snap of that classical mousetrap, but just because we hear the snap doesn't mean the mouse has been trapped. He could have just set it off.
True.
Okay, so as far as that goes, they have determined that, like a casino, when you're playing roulette, the casino doesn't know whether or not you're going to win. They just know at the end of the day they win because of probability. Mm-hmm. And that's all it is the probability of all of these outcomes. No matter the fact that everything exists in all states at any point, it's weighted. There is a part that's more likely to be than another. And so whereas there is a chance you could open that up and the rat became a little cartoon superhero and it flew away, that's more at the closer to zero possibility than the rat wanted the cheese and got caught in the trap.
Mighty Mouse has come to save the day.
So it's arguable in certain circumstances that you'd be able to influence it, like if we wanted to talk about entanglement, if you're looking at two particles that are entangled with each other, whoever observes it first will lock the other one into place.
Well, I mean, but Poda, what you're saying is kind of also like, I don't know, a finger in the pudding as far as, the scientific experiment. Can your observation or your preconceptions influence the outcome?
Yeah, the quantifiable absolute answer to the reality based on what we're observing.
Well, then you also have to realize that observation and perception is also subjective. Me having blue eyes compared to someone who has brown eyes, like I'm color deficient, and it all has to do with the rods and cones in my eyes. Me seeing a blue sky is way different from, one of you guys seeing that same blue sky. It'll be different from me to you. It's both reality, but it is subjective.
Right. That being said, when scientists run their experiment, they try to achieve this objective answer. So the very experiment that you're putting forth is technically anti-scientific. It goes against what they're trying for. They're trying to find a real non-subjective answer, and you're trying to say, can the subjective whim influence the outcome, which would be an awesome experiment on its own. That's something else.
Well, it's just because when you try to account for all outside stimuli that could influence the reading of the answer, if we don't know how all those aspects work, we can't account for all interference, is what I'm saying.
That's true. And then a lot of scientists are saying that very thing. And that's why especially the ones that agree with Einstein.
Shenanigans.
Yeah, that's why Einstein called shenanigans. But the ones who believe in the multiple possibilities going all at once, they believe that that's the source of the multiverse. That when you observe that, we'll say you flip a coin, whether it's heads or tails, it's both until you look. When you look, you're looking at it as heads and as tails at the exact same time. But you can't process that being a physical person. So now there's two of you. One of you observed a heads, one of you observed a tails. And the second you told someone, that person heard you say heads, and then it created a second one of them that heard you say tails. And it spreads like a virus, only instantaneously, to split us off into two dimensions, where in one dimension it came up heads, one dimension it came up tails. Now we've got two complete lives dimensions that are running completely parallel, except for that one flip of a coin, except every single atom is filled with all of these possibilities on a regular basis. And so every nanosecond we live, we're branching off into more possibilities.
So given that theory, it's exponential for every single choice, every single interaction. You can never actually nail down a specific number of multiverses, because for every fart you have, there's somewhere else where you actually shit your pants.
Gamble and loss, baby. Well, yeah. And it's not just that for, if I want to be single-minded and be like, oh yeah, the universe revolves around me, so it's all my independent choices, but it's not. It's everybody. So each individual person has these branchings off, and there would be like an innumerable multitude of multiverses.
And it's not even decisions by scientific standards. It's just existing. This rock could spontaneously turn red at any point because of all the atoms in it have that possibility. So every millisecond that passes by, decision or not, creates another multiverse.
So if we took quantum theory basis to analyze the existence of the spiritual realm using that theory, I see that comes back into the observation thing for me, though, because if you're trying to observe it, but we don't know how to observe it, you're corrupting the data.
Well, and if you're talking paranormal phenomena and stuff like that, I mean, there are people who are more sensitive and people who are not as sensitive. So even two people standing in the same room, one person could observe or perceive something supernatural, whereas the other person is totally oblivious to it. Does that create two different universes? No, you guys are still in the same universe, but one perceives it differently because observation, again, is it's subjective.
So then every room you ever enter, before you enter it, has a ghost in it.
It does and it doesn't.
Yeah.
That's the thing about quantum physics is not only that, but as you're saying, some people are more susceptible and some aren't. In another alternate universe, the other person's more susceptible and that one isn't. And it's all... So either as far as like explaining paranormal phenomenon, maybe you're getting a glimpse into one of those alternate universes that have been created.
Yeah, that's why there's the Berenstein Bears and the Berenstain Bears.
That's the Mandela effect. We need to talk about that in another episode.
Yeah, I was going to say that's a whole other.
That's kind of part of it, though.
That's a whole different topic of discussion, because for me that's a whole other episode, because I've seen a lot of stances made on why it is. I've seen a lot of stances on why it isn't. I have my own theories on a few things, but some of those things brought forth to be like, this is why it's happened, and some of them being like not specifically the Berenstein and the Berenstein Bears, but like just logos of companies like Febreze. I'm like, the bottle's different. I'm like, yeah, companies change their logos all the time, and they don't have...
You're getting into it now. Don't get into it now. We'll make that an episode.
Maybe that should be an episode, but it does kind of tie into this because they both are and aren't, you know? It just because, you know, maybe it's always been one thing and you would swear that it was, that is observed by you and it is true to you. So it is, but it also isn't.
See, and that's one way you can take it too, is if nothing is locked down until observed and everybody's observations are different, then reality itself is subjective. And
well, I mean,
and no matter what you do, perception is reality.
Well, I think reality is a constant, but our perceptions dictate what reality we perceive. But there is a base reality, but our perception is fragmented based on our own opinion.
Well, what makes you say that there's a basic reality?
Yeah, it's also influenced by brain chemistry, your hormones in your body. Things like this are all of those fingers in the pudding that influence that decision to go and be skewed through that particular observation.
Yeah,
past experiences, things you've watched. Well, what I'm saying is, what if the concept is that there is no one actual reality that binds us all? Each one of ours is so completely unique, and they only overlap enough for us to communicate to each other. My red is really blue, but you guys call blue red. So when I say red to you, we're talking about the same thing, but it's completely different to me.
Yeah.
Yeah, no, I
go with that. I
agree. I agree with that on the perception level of reality, but I do believe there is a base reality. We just can't completely perceive it in its entirety because we do not have the capacity to do it as individuals, or even as a collective, because we all perceive things differently.
All right, you ready for
those rare few that can pierce the veil?
But given my observations in life and understanding of structure, and like there has to be a base for everything. Even though we don't understand how everything works, everything does have rules on how they work. We just don't understand them all.
That's what I believe.
You know what's kind of funny is I also believe that there's like all the scientists piggyback off of other scientists who have done work before. They, those scientists have done a certain amount of work, taking up their, studies from that point have continued on, you know what I mean? And they aren't all from the same country, so I think some things could be lost in translation. So, this one guy says that, it's the work of a phantasm, whereas one translation says, it's a ghost. Another one says it's an unknown activator. And so, like, that little bit of mistranslation could carry that secondary scientist into a totally different conjecture from what the first scientist is leading to. Does that make sense?
I see what you're saying.
It's worked out really good for us because it's so close. But what if some things have been lost in translation and a lot of this science was on the brink of discovery, but one or two words just getting skewed a little bit, or like a turn of phrase or something like that, have pushed us into a different path.
The main language that they're all speaking is mathematics. That's universal. You can't really get that wrong. And anyone taking the research from another country, they are reproducing these original experiments themselves based off of the mathematics of the formula that have been devised, and that is a universal language. Other than that, I'd see what you're saying.
To a point, but the theories that lead to the beliefs from these formulas, the scientist writes a report. You know what I mean? And they make conjectures and things of that nature. And so what if it would lead a scientist into a totally different, like we find the cure for AIDS, but the original scientist that had started the work was really trying to find a cure for the common flu. Like, you know what I
mean? That actually, that's what happened with quantum physics. They weren't trying to find quantum physics. They were running a completely different experiment. I don't remember what the original goal was, but somebody turned the temperature up too high and blew a bulb in their cathode ray, and it generated this result. And they're like, hey, wait a minute. Huh. And it started a whole thing, but it was an accident. And it's one of the few times in the scientific journals it was written down, this was an accident, because now they teach you as you're a scientist, like go ahead and own all the mistakes you've made, but tell them that it was, fortune and not mistake.
Yeah, that's true, because an accident could lead to a completely different and new discovery of some sort.
And that's what I find fascinating about all these separate sciences, because they're all connected, even though they don't talk to each other. They keep themselves separate. Like, they all plagiarize each other to a point, but when it comes to understanding the nature of everything that we're trying to achieve, it's all interconnected. And if you're not reading what someone's doing over here and sharing what's going on over here, you're not going to view those connections, and you won't be able to actually measure what you're trying to do because you're not taking into account what Phil down the hall is taking into account.
Okay, so Einstein and Rosen, when they were originally, they were working with quantum theory a lot, and they had two completely separate projects they were working on, and one of them was talking about black holes and the Einstein-Rosen bridge, the wormhole effect that you can go through a black hole and basically be somewhere else. Meanwhile, they were arguing about quantum theory and quantum entanglement, to be specific, where if two particles become quantum entangled, then they can exist spinning up or spinning down at the exact same time until they're observed, right? Well, you separate them, don't even look at the second one, and as soon as you lock that first one into position, the second one automatically locks into the opposite position. And this is quantum entanglement. And Einstein's arguing, you can't do that. I mean, if you've got a pair of gloves and you keep the left one, the right one's going to be over there. There's no mystery about it. And while other people are talking about this whole Schrodinger thing. And nothing was settled in Einstein's lifetime. Theorists today have found out that the one that Einstein and Rosen were working on explained the other that Rosen and Einstein were working on. They were actually the same theory, and he never thought to put it together himself. And now modern quantum theorists, like you were saying, just didn't get the memo, and they finally put it together, and now they can't go back and tell him.
Yeah, that's funny. That's interesting. Yeah.
Okay, you ready for the next level of weird that quantum theory gets to?
Bring it.
The world is a hologram. That because of this whole Einstein-Rosen bridge with the black holes. Now, black hole, they believe, is anything approaching it. There's an event horizon. No light can escape it. No matter can escape it. But as you approach it, time slows. And so as you watch, like, say you threw a pocket watch into a black hole, you'd see it get closer and closer and slow down and eventually freeze right there on the limit. Because anything past that, not only can you not see, but time is frozen. So the only way to explain that is the data from that watch, the physical properties and everything, is stuck in a film around this event horizon around a black hole. And so a black hole on the inside is irrelevant. On that event horizon, it's everything that ever fell into it is stuck there, and it's slowly radiating out with antimatter. And this thin film has all the information it needs for all the depth of what's really inside it. So they feel that the very fabric of space has this too. And so everything is a flat, two-dimensional data field that contains all the three-dimensional data that is our universe. And we're living inside a sort of holographic matrix.
Yeah, there's your flat Earth for you.
And that's why black holes and planets and everything is because this data gets that entanglement where the two separate parts can be interacted with each other. And those entanglements create the very fabric of space itself. We're all a hologram.
So
under what direction, under what device?
So everything that we know as reality is that space in between that we can't clarify when the particles move from in between those spaces.
Basically, yes.
That's trippy. Never heard that one.
So everything that does exist is what doesn't exist. And it really, the more you study into it, and this is, it sounds like, Socrates on top of a hill just telling you what he thinks, but all of this is derived from lessons and scientists getting together and doing experiments and all the answers coming out right so they know that they're onto something. And this is what they came up with. And the deeper you dive into this, the weirder it is, the more wonderland you get into.
I also considered Socrates specifically after you explained that, except my animation in my head was different. It was someone else coming up to him, saying what you just said to me, and him just slapping them.
Socrates, suck on these.
That I find that more interesting than the theory that we're living in a Matrix type scenario with computer generated.
I mean, that's what I'm saying. I'm like, who's the architect in this phantom hologram kind of situation? But I don't know. Aren't we all our own creators based off the observations that we have? Like Lee was saying, red could be blue and all that kind of stuff. Well, you call it red, but it would look different. And, in the hologram, things could be different. But because of our ability to communicate, we've said that things are the same thing enough. So for me, saying that Pota's tall, if he looked short to Lee for some ungodly reason, I don't know, Pota's freaking tall, but he would say, "Oh, that means tall." You know what I mean?
Yeah, and there's two ways to look at it. One is, are we all creating our own universe, or are we all just translators of the same language, of the same world, and each of us is our own language to observe the same thing?
Hey, that's trippy to me. Like, that's something that I've always thought about, has always really made me think about things. Like, am I observing the same thing as you? I mean, shit, to put it in more layman's terms, Hitler didn't think that he was doing anything bad. Like, he translated, "Oh, this is a good idea." You know what I mean? And
he was half Jewish. What was he thinking?
Yeah, you're fucking crazy, man. But it's like that same kind of situation where we're all the creators of our own universe, so to speak.
I don't believe I'm the creator of my own universe, because it would be in a hellacious universe of reality if I was left to my own imaginational perceptions and locked on to thoughts that I have had.
You know what, though? It is.
Haven't you been? Yeah. Aren't you sitting in quarantine in your room in the dark right now? Who did that? Nobody. That was a decision that you made. That was a reality that you created for yourself.
Let me clarify.
Your reality includes a you with that kind of imagination.
Let me clarify. I mean, I would literally look out my window and that's a brontosaurus. It happens to be on fire, but that's okay because it's a lava dinosaur. Like, my imagination would go.
That is your dreams not being limited by physics. That is you creating your own world. You have the universal rules that you still have to follow. So you aren't allowed to do that lava dinosaur. but in your dreams you still can, or in your imaginations, like you just literally told us about it. That split us into two dimensions. In one dimension, that was real. In this one, it isn't.
Now, you're also talking about people who have been put in asylums who do actually believe that thing. Now, their observation of it is that it is 100% real. They can smell the lava brontosaurus or whatever the hell, and everybody else can't observe that. And so, no, that makes you crazy. So what makes reality and what makes the actual universe? Is it the idea, like the support of others observing a similar thing, no matter how they craft it in their minds, like red, blue, that kind of stuff, off the basic ideas of that communication to quantify that this is real and this is not?
That's all it is. It's social. It's you are crazy because everyone else doesn't believe it, not because you do. Say, there's a man out to get me. There's a man out to get me. There's a man out. Lock him up. He's been saying that for 26 years. And the second they lock him up, the man finds him in there and kills him.
But that's not always the case, though. You know what I mean?
But what I'm saying is if it can't be disproven, you can't be crazy for it. But the way we've got things set up, you are labeled crazy if it goes against the majority. Like Copernicus was crazy. He wasn't crazy. He knew the truth about the movement of the planets and stuff, and he was persecuted for believing what was crazy, but he wasn't crazy.
Well, these other guys too. You believe in Sasquatch? You're not crazy. You can't prove Sasquatch doesn't exist.
Right. But socially, we're all going to go, ha ha ha, you're crazy because we would have seen it by now. Well, that's all I got.
See, what's funny is that people say that, there's there's still new species discovered every day. Every day. Neppets, you care to weigh in?
I don't really understand it, nor do I have an interest in any of this. It seems like kind of like a waste of time, in all honesty, from me, just point of view, you know what I mean? Yeah, everybody thinks it's going to be different, it's going to look different, but, thinking of, it just seems like thought games, like, oh, this could be this or this could be that, and I don't know, what good does it actively do?
Have you never cared? You don't have the curiosity? You've never cared to ponder?
Well,
not the topic specifically that you're talking about tonight, no. No, I have not.
Even among scientists, a lot of people agree with that. They call it more of a philosophy than a science, because what does it matter? We found the answers. We know how to math out how big a wave is going to get when the wind's big. The rest of that is a stupid waste of time because it's all conjecture. While the rest of the scientists are saying, no, we need to find out why, because this is the ultimate search. We want to find all of the answers.
Yeah, it's kind of like the meaning of life from a scientific point, not like a religious point.
Right, but there's there's that practical side saying, why bother? What you're saying, all of this what if doesn't matter. Red is still red to me. I'm still 6 feet tall. Nothing you've said changes anything. I still have to pay the rent on the first.
Mm-hmm. I do find it interesting that looking in the history books about scientific endeavor and scientists throughout the ages, it began with an understanding that God does exist and we want to understand his creation from our standpoint as best we can. Then it steered away from that to the point where literally attempting to disprove God's existence and that science is absolute and that is all a farce. And now it seems like there's two separate branches in that. There's the scientists that are on that side of trying to prove that God does exist by understanding his creation, to the other side that still want to disprove. And in some aspects, I've heard and read articles that some scientists have been ostracized by just uttering certain words in their fields, and their papers being ripped up and metaphorically or not, just because. And for me, regardless of what side you're on in the argument, if you're all in the scientific field, why would you be trying to knock down someone who's trying to progress the entire thing of understanding of human existence? You know what I mean?
Actually, that's a really good point, and I never had thought about it that way. But, whether or not there, is a God or whatever, this is here, this is us, this is our reality, as it were. And people are just trying to quantify it and like put it into a meaning of understanding. So not all scientists have to be atheists or anything like that by any means. But, you're right. It has become this black or white kind of concern where scientists are ostracized because they go to church or something stupid like that.
And you see, I personally would blame, oh boy, I'm throwing the word blame out. I would blame the religious side more than the scientific side for that very dichotomy, because originally, when it was the pursuit of finding God and finding the answer for his creations, and then scientists were saying no, because of your faith, you have faith that this works because of this. You're not finding out why it's working. You went ahead and jumped to your conclusion and trying to make your equations fit the answer. What you need to do is observe it and find your questions and then find your answer. And now, whereas we've achieved a level now where we can have that both ways. You support God and the fact that he's created all of this and he's made these rules or whatever, so you can still pursue your science. And scientists can still say, we're leaving God out of it for now and we're just going to find out the answers. And the two sides will always fight each other, not because of the means to an end, but because the supposition of the end before you even get to it.
Well, you threw out the word blame, and I don't want to put blame. Both parties are involved because there are just as many things from the other side as a scientist trying to create a tonic to cure a cough or something like that. And somebody's like, "Oh, I have faith that I'll pull through this," and then they end up coughing and they die, and then the scientist goes to their family. Where's your God now? Like, there's just as much back and forth on that whole thing. It's not right to put a blame on any one party. It has been a to and fro over the years.
Now, I do understand the opposition, though, by placing the subject of faith and the conclusion above the scientific theory that is supposed to be in the scientific community, where you create an experiment and you repeat it to get the outcome, but you already have the outcome and you're trying to backpedal. But that's just kind of back engineering, which we do anyway, if you're looking at it that way. Or reverse engineering.
Well, that's why there's always a control, in a proper scientific experiment and proper scientific procedure, there's always that control that is unaffected, so you can see the effects of whatever affluences are going out. You know what I mean?
Right.
Yeah. I can understand both sides of the argument, but I still come back to, why would you want to knock anybody down who's still trying to progress? Even if they're going about it differently, that is contrary to the traditional standards. That's how we got a lot of breakthroughs, not just by accidents, but unconventional thought.
Oh, totally.
For example, Tesla, I think, was an amazing individual who was technically, I think, a wizard. He was an electromancer. It was crazy. It was awesome. It was amazing.
Yes, definitely. So let me go ahead and amend my blame and say it wasn't because of the religious half or whatever, but because of those outspoken people on both ends that were too far to make it an issue, who weren't willing to walk the line that were.
And I think part of that is also a basis of personal bias. And initially, maybe the head of this scientific community and the head of this religious community, they didn't see eye to eye, personally. And those bias came into thing. And in mob mentality formation, now everyone who backed the scientists is saying all these religious people are kooky, and vice versa,
And I support healthy opposition to a point, because that's just how things work. When you're trying to compete with someone, you both are growing because you're trying to compete with each other. Hence, in that theory, it still happens every time there's a war or there's not a war, because the scientists for each country are doing new methods or doing new techniques that will end up getting across the globe.
Yeah, ultimately, everybody wants. I'd love to say that everybody wants everybody to succeed, but really, that isn't the genuine case.
Yeah, succeeding first is more important. But when you rush, mistakes are made. Like, it's cliche, but one of my favorite lines in the original Jurassic Park movie, I think that isn't really memed or talked about when people talk about Jurassic Park, was the chaos theorist guy who, when he said, your scientists were so preoccupied if they could, they didn't think if they should. I think that's a very big statement. Because there's a lot of things like, could we do this? It's like, but should we? Like, just the idea of bringing dinosaurs back in modern day now, which is being talked about with CRISPR and cross DNA and all that stuff. But it's like,
Right.
Should we? Because of how the ecosystem is set up right now. And then
How do you answer that, though? Like, that is a should we? Who gets to say whether we should or not? Sometimes
Yeah.
some advancement won't happen because we're all afraid of it, because we all think it might be taboo or something. And that has held us back in the past until one guy says, F it, I'm doing it anyway. And then we're all like, oh boy, we're glad, I'm so glad that Madame Curie decided she was going to mess with that radioactive stuff. Yeah, it killed her, but the rest of the world has benefited from it. And but to go back to her time, she shouldn't have.
Yeah.
Yeah. I don't know. This is really interesting stuff. This is stuff that I have thought about a lot, and I find it very intriguing. What is the benefit of having a discussion about this? I don't know. And do I know anything more before this conversation or after? Neither, I guess. But the fact of the matter is that it got my brain juices flowing, and the possibility of creations and stuff like that. I don't think that we should ever bottleneck ourselves or clam our brains up from thinking of the possibilities, because that could lead one person to become a scientist or anything like that. And maybe somebody hearing this will get a bug and discover ways to create sustainable antimatter or something. Who's to say?
Yeah, no, I support broadening the mind to the understanding of the world around you, and I've always found it interesting when, whether you're with a group discussing something or you're on your own and you're just thinking and daydreaming, as they say, and you start to make connections and your brain starts going in a direction, and then I don't know if it's happened to anybody else, but all of a sudden you get a massive headache and completely forget everything you were just talking or thinking about or get to that point. And then whenever that happens, like your brain just goes numb or stops or just like it short circuits. And then the times that's happened in my life, the only thing I can think of afterwards is, does that mean like I was really on to something and I'm not supposed to know? Or I was working my brain in a way that it can't go. Like I don't have the mental capacity to understand that.
Like Lee said, you blew a fuse.
Yeah.
Yeah.
No, I like it. I like pushing the bounds of understanding and the acceptance of the norms. Any way that you could try to expand your mind, expand your thinking, expand your possibilities of your thinking. Even though that headache happened and maybe I got to stop thinking about this now. You might come back to it in a couple weeks and go a little bit further with your ideas and your thinking. Your mind is ever expanding. I mean, it's not a deferential sponge. It's like infinite. We can always absorb more information, and people taking that idea and running with it and talking to peers and expanding the idea, because you can only also go so far, just thinking by yourself in a room. I only think that could benefit humanity as a whole.
I agree. They say that it's not a sprint, it's a marathon. Well, I don't even think it's a marathon. It's a relay race, because once you've done running, you pass the torch and they can go on from where you left off. If you're trying to think so hard that you blew a fuse, maybe it's not saying you aren't meant to think of that. Maybe you are just tired of running and you need to take a break and reboot yourself and get some rest. Or you talk it out with someone, to help, refresh it and bring in some external stimulus to help things keep going. You might be burning out because you're going too hard and too fast on your own without taking room to breathe. Try to take in more, open your mind up to those other possibilities. Other than what you've, in a fever pitch of scribbling on the walls, this scientific breakthrough that you just thought of, and now you're up on the ceiling and your left arm gets loss of blood because you're writing on the ceiling, and then when you step back, it's all just scribbles and you look like a mad crazy man.
You got red yarn attached to like little pins on the walls.
Yeah. My brother, he's still watching. I know it's connected.
And right there, I believe that's two groups that should be talking to each other. You say, with math being the universal language of science and stuff like that, the people that really study sacred geometry and stuff like that, they're separated because it's like, oh, no, you're crazy. But then if you really get into numerology, well, it will drive you crazy. I left that behind because I started to lose my mind a little bit. But that's why I left. That's why I'm not good at math anymore. I made sure to delete a lot of shit from my brain. But the fact of what they do in that theory and what they study and basically trying to create a formula and understand the mathematics that account for everything specifically. Like, I think it'd be cool to, I would like to, I put that out there right now. If anybody's listening and happens to be a quantum physicist, and if there's also someone out there who is a practitioner of sacred geometry, I want you two to talk. I want to hear what you have to say. I want to hear what points you make, and I want to hear a discussion between those two individuals.
I bet you that there was a lot of crossover. Like, obviously it's going to be hushed because the two are so separate. One is definitely shunned by the other, but there has to be crossover where, yeah, I grew up, I was a physicist for a long time, and then I discovered the relationships between this and this, and so they've classified me as a numerologist now, and I can't be a part of the regular physicist's world. Or the other way around, where I got so good with my numerology that people started taking it as theorems, and now I'm a scientist, and so now I just have to pretend that it's not numerology.
Well, see, that's where it gets kind of finicky, though, because, I don't know. I guess a scientist could be just as susceptible to that, but like numerologists, in my understanding, it's like, oh, this is this ancient number. Let's just say, 9. And so they draw conclusions to point everything to 9. And yeah, sure, maybe it's stuff that's divisible by 9, but maybe it was actually supposed to be 27, you know what I mean? But they simplified it to 9, and now everything points to 9. But if you had 2 and 7, it's 9. Like, you know what I mean? Like,
yeah, but that is also a group of people working together, and so at some point it's got to have some sort of correlation, or it wouldn't have even held together.
And that proves the interlocking connection between everything, because you can work it all the way back to 9. Like when people put those names out there and then they quantify, it's like, well, this name registers this in these numbers, and like you wouldn't be able to do that otherwise if there wasn't an underlying connection between everything that can be quantified. We just don't have the capacity or the material to measure it right now.
Well, we've also got the psychological ability to connect any two things, that whether they connect or not.
Yeah, exactly. Just like you can read a horoscope. I guarantee you, what are you, Poda? A Taurus, an Aries? You're an Aries, right?
Aries.
Yeah. So read a Capricorn on one day. Cover up all of the titles of the horoscopes with a little piece of tape or whiteout, and you read one, and I almost guarantee you will just as much correlate your life to like a Capricorn as you would to an Aries, because it's so general, and you make those connections for yourself because it's all subjective.
That's what we touched on in the Zodiac episode. It's that very thing. It's because your brain finds patterns. The human mind will find patterns in things, whether there are patterns or not. And the real trick behind all of this science is to discern what is you creating the pattern and what is the pattern that is there already without your influence. And we're limited to observing it ourselves. We are our own contaminant. So that's making it awfully difficult to
well, but that was a base example. But yeah, that's what I'm saying with reading the findings of a different scientist. You can pick and choose and kind of make your own conclusion. Regardless, if you read the report, they say, oh, this could happen. So then you can think maybe this could happen, and maybe you have your own experiments that were trying to support that. And then you could find out things based off of that, but maybe that isn't what the original scientist was initially putting forth at all.
Yeah, and that's what separates, I think, the level of scientists is the thoroughness, that because if you're thorough enough, you can finally work yourself out of the equation. And I think that's what separates the really great minds from the mediocre ones are the ones who are able to take it to that next step, regardless of what you thought, regardless of how you understood it. And you're coming up with conclusions that have nothing to do with how you felt about the original.
Right. That's why I like those experiments that, they have a conjecture, they have a hypothesis, and they're trying to prove themselves wrong. But sometimes they can't. I like that approach. Like, I hope I'm not right in this theory. So let me try to prove myself wrong. And if you can't, shit. You know what I mean? Like, it didn't have anything to do with me.
Well, that is in its own way biased. It is preferable to the other way, but that's biased too. You really have to try to be open-minded through the whole process if you're going to get any sort of accurate answer.
And that's amazing to me that just the idea of observing it changes the source for the answer we're trying to measure. So how the fuck are we ever going to measure anything correctly by trying to observe it? It's like, okay, we're going to measure this. How? Don't look at it. Don't think about it. Don't. Okay, well, then what's the answer? It's not for us. We can't figure. Nobody in this room.
All right.
Can figure this out.
So there has been a couple of practical applications to quantum theory that have changed our lives. Just to bring this back down to the reality of it, most of our computing, all of our circuitry and everything is based on the quantum theory and quantum entanglements. That's why we have a binary systems of zeros and ones that make the computers work. They now have a quantum-based bit for a computer, for a quantum computer, a qubit, they call it. And the problem is you have to keep it at a temperature near 0 Kelvin in order for it to even work. So it's real expensive. But they made a 54-qubit quantum computer where all the zeros and ones can exist at the same time. And so it can do calculations exponentially faster than anything ever on Earth. If they can come up with a kiloqubit, 1,000 qubits put together, they will be able to compute more than all of the supercomputers on Earth put together can right now. It's amazing. And so they're actually taking this quantum theory and making it real.
On everything?
Well, see, and that's the trick, is right now they have to have input and output based on regular bits because we have one reality we have to lock into. And so those processors are heating up the qubits above 0 degrees Kelvin, or now it's allowed to be like 1.5 degrees Kelvin because they found a new way to make it. But anyway, but the nanocomputers are heating up the qubits, so the outcome gets all fuzzy. And so the trick was isolating the two so that way they can interact with each other and still give us the one answer in our reality that we're looking for. And so far they've been able to make a 53-qubit computer, which is like amazing because until 2 years ago they were only allowed to get 8 together before it all started falling apart. And they've gotten 53 together, and any more than that right now breaks apart the reality, and we can't get the one real answer anymore. And it just says all answers are real.
So we created a computer that breaks reality.
Sort of. I mean, it exposes the broken reality. It doesn't break it. It doesn't make you speed. It just pulls you over.
Because you see, reality was already broken until we could observe it.
Exactly.
And we broke it by looking at it?
No, we looked at it and realized
because it wouldn't have been broken until we observed it. Because it would have been all of it. And it would have been working.
No, it's broken without being observed. We just fix one piece of it.
Well, then how many pieces is it made of? Which piece did we fix? Yes.
This one. And that's the thing with it infinitely splitting off. By definition, whatever we're observing is the one that we went with.
Oh, true enough.
That's all we can do.
Okay. So this computing power, what do we term it as? Is it literally just a machine that does calculations?
Right. Yeah, they're literally trying to just build a computer that can compute like regular computers do, but using quanta instead of electrical impulses, or a combination really, but using quantum mechanics, so that way it can be either a 1 or a 0 or a 1 and a 0 at the exact same time. So it's got that ethereal state to it. So instead of like if you're in the center of a maze and you're trying to find the exit, you take one path, you hit a dead end, you double back, you go to the next one, you hit a dead end, you come back, and then you eventually find the exit. And with quantum computing, because it's in all states at once, it just goes out in all the directions. The one that finds it, it stops and it says, that's the right one. And so it finds it millions of times faster.
Now, that's a little bit scary to me in the sense of theory. And if we made one with enough qubits, would that be along the lines of going down the road of the AI scenario? Because
AI
being aware.
If we applied it to AI, that would be the most dangerous, potentially dangerous combination.
What I'm saying is, if we're not careful, if we put, with it being, to my understanding from what you said it does, it's only limited by the qubits it has. And just the number of qubits we've got to is vastly superior to our understanding, to the point where it can navigate reality. If we try to make it even stronger, I guess maybe like a science theory movie or whatever, like, would it become self-aware because it would understand its existence in reality?
It's still being controlled and limited by the parameters we can give it. We can't just set it free and say, go ahead and be whatever you want to be when you grow up. It's still a computer. We're still telling it, is
this is your function.
Yeah. What is 2 plus 2? And it goes through all the numbers and says 4 is the only real answer. It's not going to say, we're not going to say what is 2 plus 2, and it's going to say, I think I'm going to go to college.
It's time to be self-aware. I have feelings.
I don't know. That's just the thing. That's my brain is what my brain is short-circuiting on, is if you keep increasing the power of it from where it's at right now, it would understand its existence and awareness in reality that it's computing.
You're not bringing it awareness. It's still just a computer.
No, I'm not saying bringing it. I'm saying it discovering it on its own through the ones and zeros and understanding of reality.
If you put enough blades of grass together, it doesn't become a cow. It's not going to become self-aware because that's not its nature. That's not on the table. It's a warehouse full of shoes does not become a starving child. Although you might see that result from a warehouse full of shoes. But even if we got to the point where we decided to feed an AI program into it, which would cause a scenario that you're worried about, you don't have to be worried. It could be a benevolent AI. It could be someone nice. It doesn't always have to be this Asimovian conflict where you're worried about killing people. I'd find the idea of a kind AI, I find highly unlikely, in the sense that we have already, to our human understanding, have come to the awareness that we do not coexist in our Earth, in the ecosystem that things are set up in. We trounce, we take, we mold, we're not within the system. We are making the system work for us and fucking it up.
Well, you're getting into the basis. Okay, so this is becoming an AI conversation, which should be reserved for another episode. Where, what Lee is saying ultimately with the qubits and stuff like this, it's pretty much like a processing speed and not necessarily a programming issue. So there's no AI involved. It's just making it faster to process the capabilities. You know what I mean? Like,
okay.
We have had, AI should be reserved for another episode, ultimately. That's a good episode.
So, that brings up a whole bunch of interesting things. It's basically a waste of time or the answers to the universe. You take your pick. I hope this episode's got some of you thinking out there, got you some of you discussing. Feel free to leave some comments. Let us read some for a change. And until next time, I'm signing out. This is Dr. Lee saying good night, everybody. Thank you for joining us on today's episode. If you have any thoughts or questions on today's topic, please feel free to leave a comment. Or if you'd like to contact us directly with any feedback or ideas for future episodes, you can email us at ratingthefringe@brainforger.com. Be sure to like, follow, and or subscribe. And for any future episodes, tune in to Facebook, Spotify, Libsyn, or wherever it is you get your podcasts. We look forward to you joining us next time as we raid the Fringe.